Welcome back. In this video, we are going to solve a structural design problem that involves a one-way slab design using LRFD method based on eStructural Design Zen found on the App Store. Design a reinforced concrete one-way slab using load and resistance factor design for residential use with simply supported span of 4,000 mm and assumed thickness of 160 mm. Design criteria as follows. Strength of concrete 21 megapascal, main bars 10 mm bar grade 276, temperature bars 10 mm bar grade 276. The uniform load for 160 mm thick slab is 3.84 kN per meter. A residential live load is 1.92 kN per meter. Other dead load, like floor finish and partition, is 1.92 kN per meter for a factored load of 9.984 kN per meter. Enumerate input parameters required. Name of slab S1, type of support simply supported, length of span 4,000 mm, slab thickness 160 mm, main bars and temperature bars 10 mm bar at grade 276, strength of concrete 21 megapascal, and factored load 9.984 kilopascal. Given factored load equals 9.984 kN per meter and L equals 4 meters, the maximum moment is 19.968 kN meter. Given maximum moment equals 19.968 kN meter, B equals 1000 mm and D equals 135 mm, the beam design ratio Rn equals 1.217 megapascal and reinforcement ratio ρ equals 0.00457. Use ρ minimum of 0.00507. Given ρ equals 0.00507, B equals 1000 mm and D equals 135 mm, the area of steel for main bars is 684.45 square millimeters, and the spacing for 10 mm bar is 110 mm. The area of steel for temperature bars is 320 square millimeters, and the spacing for 10 mm bar is 245 millimeters. The shear force from dead load is 11.52 kN and live load is 3.84 kN for a factored shear force of 19.968 kN. The nominal shear force is 26.624 kN, less than 105.17 kN concrete capacity. Design recommendation as follows. FC prime equals 21 megapascal, Fy equals 276 megapascal, length of span is 4000 mm, thickness is 160 mm, main bars of grade 276, 10 mm bar at 110 mm on center, bent up alternate at 1000 mm, plus extra top bars. Temperature bars of grade 276, 10 mm bar at 245 mm on center. Thank you for watching. If you learned something from this video, please like, share, and subscribe to this channel.